So this question is about you're given a cardboard. It's originally 30 centimeter in length and 25 in width. And each corner there is a square with the side length x being cut. The x can vary, and so then each side then being folded up to form this kind of box without the lid. So you can see the height folded up is exact same as x, and this is going to be the length of the box, which is the 30 in total, subtracted 2x, at the two corners, and then this would be the width is actually use the 25. 25 is originally from here all the way to bottom. So subtract 2x, so we would have a width like this, and then the x is the height. And to find out the volume of this box, we just use this Vx as a function of x. A volume of a rectangular prism is just length times width and then times the height. So that's exactly here, this length, width, and x is the height. So this is the volume. And this is if you expand it, you're going to form a general cubic polynomial function. But we don't need to expand it. We just keep this standard form, which is actually easier if you want to graph. You can also tell the zeros should be x equals 0. So this would be x equals 12.5. This would be 15. So there's 3 zeros you can expect. Okay, let's graph this in GeoGebra, the software. So let's shift back to the GeoGebra software. Now here you go. So here we can just type in y equals multiply x, then multiply 25, subtract 2x, and then 30, subtract 2x, enter. Okay, now we find the function. Now if you can examine here, that's exactly the function we need. So you can adjust all this to make it better looking. Make this wider. Okay, now there's a difference between the function representing the volume and the function just graphed here. So if there's no restriction about the x can be negative, it can be positive for any numbers, all real numbers. So you can see the graph actually can go downwards. Now what does that mean? If you pick any point here, it means when x being -1, for example, so the volume is negative something, so that doesn't make sense. So just be careful, all the x you can use has to be 0 to 12.5 here, and it doesn't make sense when the x is greater than 12.5. So why? You can come back to see this. Look at here, if you cut a corner, so the maximum, because we cut the corner at cut the square at each corner, so you can see the maximum part you can cut must be less than half of 25, which is 12.5 centimeter. So it can't even be 12.5, otherwise you cut this two corner, and then there's nothing can be folded up on this side. Okay, so and then basically x should be from 0, bigger than 0, and then less than 12.5 centimeters. So let's put it here. X should be in the range of 0 and 12.5 centimeter. Okay, in between these two numbers. Okay, let's go back. Now, according to the graph, you can see If we can make this a little bit bigger, a little bit wider, because we don't really need to see the graph outside of this range, 0 to 12.5. And you can see when x increases, you can see the volume also increases. And then when you get x becomes about 4.5, we don't know exactly how much. When x above 4.5, so it looks like the volume becomes maximum. If you increase the x further, so the volume x decreases and until to be 0 at this point. Okay, so use this technology, we can find out exactly what kind of x can make the volume becomes maximum. So you can type in here called x, okay, extreme, and then just put f. So you can see extreme, f is just the function we created here. So basically, so this is a internal function of this software, help you to find out what the extreme value for the x. Actually, when I pull this back a little bit, so you can see you should have one local maximum and one local minimum here. Let's see. Okay, see there's the 2 points being labeled after I hit enter. So one is A, and on this A point, obviously it's a local maximum, and on the B point is another local minimum, and this one doesn't make any sense to us. So that's the only thing we're looking for. So at this point, you can look back here. The point A has a coordinate 4.53. That's exactly the x coordinate. And then 1512.04 is actually the maximum value when x equals 4.53. Okay, so we can actually just take this picture and then put it back into the notes. Okay, so we can check that our value is when x equals 4.53, the volume is 1512.04. Okay, let's put the number back to here. So this is actually the domain. Actually, the question asking for what's the domain for this function. Can put it here. Domain of Vx is actually 0 to 12.5. So they can't be 0 and 12.5. That's why there's no equal here. And then we just use the software to figure out when x equals 4.53 centimeter. So the maximum volume, the maximum, is going to be, no, I can't remember that, 151204. 151204 should be cubic centimeter. Okay, so that's the question, and later I will cut the graph and post it here. Okay.